Hello there, welcome to my ENME489Y remote sensing final video. The target I selected this semester was the cannon located on the south side of the front of Record Armory. I chose this cannon because I think it's a really cool and unique feature on campus that not a lot of people know about. And on top of this, there are some certain distinguishable features that would stand out really well on the point cloud, those being the round barrel boxed in red and the flat shield on either side boxed in green. Shown here is my LIDAR setup. Unlike most students, I chose to mill my mount out of acrylic in a machine shop instead of using the 3D printed mount. You'll notice there are two screws mounting it to a block, which is then bolted onto a tripod on the back. One of those screws I removed and used the other as a pivot when changing the angle. Boxed in red here is the Raspberry Pi with an Ethernet cable connected to my laptop. Glued to a piece of acrylic boxed in red is the camera here. You'll notice in the middle of the board is the IMU chip. I ended up using the Level app on my phone in favor of this chip. Here is the Arduino microcontroller and the line laser, which was powered by the Arduino. Shown here is the setup when running the laser alignment code for the calibration values. You notice the laser in my case is on the right side of my image, and this was because my camera was inverted, which I later had to correct. Shown here is a brief time lapse of me taking images for homework 5 of my ukulele in my bedroom. And this largely helped me get used to using the HSV mask and running data generation for the point clouds later on.
Okay, and we're out inside the armory here taking more data for the 3D point cloud and eventually the mesh grid. And as you can see, we have my LIDAR mount there, the cannon behind me. And one thing I changed up is that I actually went to Home Depot and got an 8x10 blue tarp, and I strung it up from the tree here, as you can see, on both corners and staked it down. And what it does is it provides a nice backdrop, and it actually blocks out all of these lights that surround it here, particularly the red light on the chapel, the red stoplight, and actually the red light on top of the hotel. So my images have been far clearer, and there's been less interference from other red lights.
So here's a time lapse I took of myself mapping the front of the cannon. I ended up using a bed sheet to help the laser stand out well on the cannon surface because I found that the laser by itself didn't reflect with enough intensity to be picked up well by the camera. And this actually worked out great. I got great images from it. The only problem was, due to the front of the sheet being stretched across, you can't see under the cannon, which can be observed later when I map the point clouds. Here we can explore the PyCharm code used in data generation provided by Dr. Mitchell. Shown here are my HSV values, and I obtained 4 different HSV value sets for each of my views. Here are the constants used to calibrate my sensor, and these were found using the laser alignment code, also provided by Dr. Mitchell. If you'll notice, my H value is slightly different, and that's because my laser and camera are actually 13 inches apart on my board and not 12. Here I have 4 individual folders for each of my cannon views, and that's so when the text file, written test results shown here, is created, they don't overwrite each other. One very useful piece of code that I utilized greatly, and shout out to Trevor Appler for helping me with this, was a filter that eliminated all of the 0 points from my text files. And it just created a new text file from the old one with only the relevant points, and this actually helped MATLAB run a lot faster when I was creating the point clouds. Now we can explore the MATLAB code I used to create each individual point cloud. Here's where I import all of the different text files from each viewpoint and set it as a variable. And within these variables, I assign each point in the array to a different X, Y, or Z variable specific to that viewpoint. Here is where I assign them as point clouds. And next I create a figure using PC show for each individual viewpoint. As we can see here, shown here is the right side of the cannon. And you can see the curvature of the barrel. Here is the left, and you'll notice a very clear flat shield. Next we have the front of the cannon. As mentioned earlier, you can see that the hole in the cannon is covered by the sheet, and there is a surface stretched across the front, when in reality the cannon actually goes all the way back. And here's the rear view, and you can see we get a nice curvature of the barrel all the way up, and we get the 2 arms connecting the shields on either side. Next, there's a separate MATLAB code I used to combine all of the viewpoints. First, I imported them the same way as the other code, except this time I set each one as an array of values. Here I have all of the rotational matrices in one translational matrix for each viewpoint, and I only used the translational one and rotations about the z-axis for each viewpoint, centered on the last viewpoint, which is the rear view. Later on, I used PC show to create each point's cloud, and then PC merge on the left and right views, and the front and rear views, and then PC merge again to create a full combined view. And then I used PC show to show the full combined view, which is here. And putting them all together, I think it looks fantastic. I think you can very clearly see the barrel of the cannon, and as well as the two shields on either side. There are a few outlying points, but these were dealt with later on when creating the mesh. I elected to use Cloud Compare instead of Mesh Lab because I found Cloud Compare to be a little bit more intuitive, and one useful tool was the outlier filter, which eliminated those extraneous points that were mentioned previously. The mesh itself is very clear and well defined, except for the bottom, but that's because I wasn't able to map the bottom of the cannon for obvious reasons. But we see the shields on either side are well defined. When we go to the front though, we can see the surface that the sheet created, blocking the underside view of the cannon. But overall, I'm very pleased with how the mesh turned out, and given more chances to clean and edit the mesh, I would like to 3D print this design in the future.